All right. Hello, mis amigos. You've made it back to another round of the ITM Daily Show. I'm Richard Beamer, your host for the day, and I know it's been a while, but I have a topic to discuss with you today that is beyond not exciting. This week on the Daily Show, we'll be covering in-memory database systems. Exciting stuff, I know. So let's dive into this can of worms. Looking ahead, we'll be touching on what in-memory database systems are, or IMDb, a bit of brief history, then some varying components of the management system. Then we'll talk about some benefits and some pitfalls. We'll discuss some of the practical uses, and then we'll have a quick recap of the entire presentation at the end. To start, in-memory database systems, or IMDb, is a database management system that uses memory on a computer's data storage hardware, rather than using a disk storage mechanism. Imagine the movie Limitless with Bradley Cooper. Bradley Cooper is a computer in our example, and when he uses his drug, he's able to access all of his memory at will. He doesn't need to sift through a bunch of files or folders, and it's just readily accessible, like with IMDb, and it's pretty neat. Now, when considering the timeline of in-memory database systems, it's a bit more difficult to piece together because it is so new. But we can look at data management, data storage systems of the past and consider how we got to where we are today from where we were before. To run through it, we have dyno technology back in the 1950s and 60s with magnetic tape, cassettes, and floppy disks. And eventually we moved beyond those floppy disks. And I bet most people watching this have never even seen a floppy disk. But from our floppy disks, we see hard drives born, then CDs and DVDs. The growth rate of technology is continuing to accelerate, and we end up with USB drives, then Blu-ray, and then the cloud. And if we were to put in IMDb into this mix, it'd likely fall in between the USB drive and Blu-ray segments, at least for when it became used in the market. However, there is evidence of a database scientist named Jim Gray, who conceptualized the technology over 30 years ago while working for IBM. The first major commercial IMDb software was Times 10, which was later acquired by Oracle, and now there are a bunch, and we can see them being used in the blossoming data analytics scene now that multi-core processors can address massive amounts of information, and random access memory technology is less expensive. Now, to compare IMDb to older forms of data storage that we saw in the last timeline, this chart does an excellent job. With disk-based systems, we have the burden of carrying an I/O file. There's extra memory for caches. The algorithms are optimized for this, and there are more CPU cycles, making it slower. And it assumes there's more than enough memory. Then with IMDb, we don't have the I/O file burden. There isn't extra memory. Algorithms are set up for memory, and there are less CPU cycles. And then it is also extremely efficient with space. So one might be asking whether or not this is valid technology or worth using at all. And luckily, our friend Andreas Reuter and Theo Harder designed the ACID test, which stands for atomicity, consistency, isolation, and durability. Database systems are judged on this scale, but let me clarify what each category is. First, atomicity means that transactions are all or nothing. So if a transaction fails, nothing happens. But if it is successful, then bombs away and we make it through. Then consistency is programming errors can't violate any defined rules within the system. Then on to isolation. This looks at whether or not transactions occur sequentially or one after the other successfully. And then finally, durability. This asks the question, if a transaction occurs, will it remain, especially in the event of a power loss or crash? Will it remain acted on? That is. Now, IMDb checks all the boxes except for durability. because with random access memory or RAMs, if there's a power failure or crash, you lose any recent changes made within the system. But don't worry, for snapshot files and saving checkpoints can actually be used to maintain data security and prevent information from being lost. In addition, non-volatile RAMs or RAMs have been created that allow in-memory databases to run at full speed and maintain data in the event of power failure, which is actually strengthening its durability. Next, we can consider some of the major benefits to be had from IMDBs, and the first one being that IMDBs are fast, and with hybrid systems with on-disk databases, users can actually save costs on expensive IMDb systems by forming a balance between performance, cost, and reliability. In regards to pitfalls, in-memory database technology is expensive, but as mentioned before, that can be resolved through product development and hybrid systems. Next, random access memory volatility brings on some concern, meaning that it'd be a shame if we lost information in the event of a power failure, but that can be prevented with non-volatile systems, as mentioned before. And then finally, let's look at some practical uses of in-memory database systems. We see it being used where massive amounts of data are processed frequently in real time. For example, a company like Charter would be a large telecommunications company to use this technology to process all the information that they have to handle in a given day or given period of time, especially with their millions of customers. In addition, we might also see sites that monitor the US debt using this technology as well, given that they have to manage so many different inputs and arrange them in a chart like we see here in the presentation. So to recap, in-memory databases are database management systems that use memory for data processing and storage. It was conceptualized over 30 years ago, but now we're seeing major uses for it, compiling massive amounts, as we compile massive amounts of real-time data today. It tests well on the ACID support test, and through future development, it'll be an efficient, speedy way to maintain data. So thank you for tuning in to this week's InfoTech Daily Show. Come back next week for more exciting info.